Hi guys, let's start the next exercise, exercise 2D. There is nothing else for me to teach in terms of new concept. So let's go ahead and start the questions directly. It says Rachna borrowed rupees 12,000 at 10% compound interest half yearly. So principal is equal to rupees 12,000 and the rate is 12% compound interest compounded half yearly. She repays 4,000 at the end of every 6 months. Find the third installment. So let's calculate for the first half year. Let's calculate interest 1. So compound interest 1 will be equal to principal into rate, in this case 10 into time, since we're looking at a half year time period, upon 100, which means this is 2 1 and 2 600. So the compound interest for the first 6 months is rupees 600, which means amount at the end of 6 months is equal to rupees 12,000 plus 600, which is 12,600. Next, since she repays some money, how much does she pay? She repays 4,000. Therefore, principal for second term will be equal to A1 minus 4,000. In this case, it would be rupees 8,600. Now let's calculate compound interest for the second 6 months, which is second term. In this case, it will be principal into rate into time, again half, upon 100, which is 0 and 0, 0 and 0. This is 2 1, this is 430. So compound interest for the second term is rupees 430, which means amount at the end of the second term, which means amount after 12 months would be 8,600 plus 400, which is equal to rupees 9,030. Now again, at this point of time, Rachna repays 4,000 rupees, which means principal for third term will be equal to amount to minus 4,000, which would be equal to rupees 5030. Let's calculate compound interest for the third term, which will again be principal into rate into time upon 100, and this is 503 divided by 2, that's 251.5. Since it's money, I will write it with two decimal places, so this is rupees 251.50. Let's look at the question. It says find the third installment at the end of 18 months to clear the loan, which means amount 3 is equal to P3 plus compound interest 3, which is 5030 plus 251, which is rupees 5,281.50. So that's the money that she needs to repay to clear the loan completely. Good. Let's look at the next question. The next question that we do is question number 5. It says during every financial year, the value of a machine depreciates by 12%, which means the value keeps going down, which means we are reducing the value, which means whatever is the interest, so-called interest, the reduction value or the depreciation value, we will reduce it. Find the original value of the machine which depreciates by 2640 during the second financial year. So let original value be rupees 100, which means depreciation in year 1. Depreciation in year 1 will be 100, rate is 12, it's being depreciating yearly, which means this is equal to rupees 12, which means value at the beginning of or the end of first year or beginning of year 2 would be 100 minus 12, which is equal to rupees 88. Now let's calculate depreciation for year 2, which will be 88 into 12 into 1 upon 100. Let's do the multiplication. 88 into 12, that's 8 into 2 16, 16 plus 1 17, this is 8 and 8 6, 7 plus 8 15, this is 1056. So depreciation will be rupees 10.56. Now depreciation for year 2 is given, so let's apply the unitary method and let's calculate it. So when D2 is equal to rupees 10.56, original value is equal to rupees 100. Therefore, when D2 is equal to 2640, original value will be equal to 2640 into 100 upon 10.56. Okay, let's remove this decimal. So this will be 2640 into 100 into 100 divided by 1056 divisible by 11. So let's try 11 into 9, 99. That's 6. So that's 11 into 6. This is 11 into 22, 44. This is 240 divisible by 12. Yes, 12 into 8, 96. 12 into 2, 20. This is 4 into 2, 4 into 5. This is 2 into 1, and this is 2 into 50. So this is 5 into 50, that's 250 with 2 more zeros. So 250 with 2 more zeros, which means the original value of the machine is rupees 25,000. Good. I hope you're getting the hang of these questions. These questions will become much simpler when we look at the next chapter, where we will be able to use a formula directly without having to go through this lengthy process. But some people prefer doing it this method, which is using simple interest repeatedly. Some people may prefer the formula method, whatever works for you. Let us find the sum on which the difference between SI and CI at 8% compounded annually is rupees 64 in 2 years. Okay, so let's use a different method. Let P is equal to X. Instead of taking the unitary method where I've been taking 100 every time, let's try this method of X. So in this case, simple interest would be equal to principal into rate, which is 8, time is 2 upon 100. In 2 years, right? So this is 2 years. So this is 8 into 2, 16, 16x upon 100. Now let's calculate compound interest. So compound interest for the first year, again, principal into rate into first year upon 100, which is equal to 8x upon 100, which means amount 1 is equal to principal 1 plus compound interest 1, which is x plus 8x upon 100, which is equal to 108x upon 100. Let's calculate compound interest 2. That will be principal, which is in this case 108x upon 100, multiplied with rate, which in this case is 8 into 1 upon 100. So this is 108 into 8, that's 808 into 8, 64. So this is 864x upon 1 with 4 zeros. That's 10,000. Okay. So difference between compound interest and simple interest. So we've calculated CI2, CI1. Let's calculate total compound interest. So total compound interest is equal to compound interest 1 plus compound interest 2. In this case, 8x upon 100 plus 864x upon 10,000. The LCM of 100 and 10,000 would be 10,000, which means I have to multiply this with 100. That's 800x plus 864x, which is equal to 800 plus 800, that's 1600. This is 1664x upon 10,000. So this is total CI. As per the question, difference between SI and CI, which means since CI is always more than simple interest, CI minus SI is given equal to 64. Let's substitute values and see what we get. Okay. So compound interest is 1664x upon 10,000. Simple interest is 16x upon 100, and this is given equal to 64. Let's take the LCM, that's multiplied with 100. So this is 1664x minus 1600x upon 10,000 is equal to 64. So this is 64x is equal to 64 into 10,000, which means x is equal to 64 into 10,000 upon 64. Therefore, x is equal to rupees 10,000. So the original value or the original sum is 10,000, and on this 10,000, the difference of CI and SI would be 64 rupees. Good. Let's look at the next question. The next question we have is question number 9. Now you can put a small star on this question. Why am I saying this is important? Let's look at this question and then you'll figure out why is this important. So Ashok borrowed rupees 12,000 at compound interest. After a year, he paid back some money. If compound interest for second year is something, find the rate. So rate is not given. Let rate be R% per annum. What this means is we can calculate compound interest using this method. So compound interest for the first year would be principal, in this case 12,000, rate we've taken as R, time 1 year upon 100, which is equal to 120 R, which means amount for the end of first year will be principal, which is 12,000, plus compound interest, which is 120 R. Now at this point of time, he pays back 4,000 rupees, which means principal for second year would be amount 1 minus 4,000, in this case 12,000 plus 120 R minus 4,000, which is equal to 8,000 plus 120 R. That's P2. Now let's calculate compound interest for the second year. Compound interest for the second year will be principal, in this case 8,000 plus 120 R, that's the principal, multiplied with rate, which is R, multiplied with time upon 100. And this is given equal to 920, because compound interest for year 2 is given equal to 920. So now we'll get a quadratic equation, because 120 R multiplied with R will give us 120 R square. So let's multiply first. So this is 8,000 multiplied with R is 8,000 R, plus 120 R into R is 120 R square. Cross multiply, so that's 920 into 100, which means 920 with 2 zeros, that's 92,000. Anything common between these three elements? Yes, I can divide all of them by 4. Yes, and a 0. So I can divide all of them by 40. If I divide this by 40, this becomes 120 divided by 40 is 3R square. 8,000 divided by 40 is 200 R. And if I take this on this side, 92,000 divided by 40 is 2,300. This is equal to 0. Now I've got a quadratic. If you remember how to solve a quadratic, we need to split the middle term in a manner that the sum of the factors is equal to 3 into 2,300. So I basically need to find factors of negative 2,300 into 3, and the sum of these factors should be equal to 200. This looks quite simple. If I divide this as negative 230 into 30, but then this will give me negative 200. So then let me divide this as 230 into negative 30. So if I take the factors as 230 into negative 30, I will get 2,300 into 3, and the sum of 230 and negative 30 will give me plus 200. Perfect. So I've been able to figure out what my factors would be. So let's split the middle term as 3R square minus 30R plus 230R minus 2,300 equal to 0. Grouping it the way I've underlined, what we get is 3R times R minus 10 plus 230 times R minus 10 is equal to 0. Between these two terms, R minus 10 is common. So that's R minus 10 times 3R plus 230 is equal to 0, which means R minus 10 is equal to 0, or 3R plus 230 is equal to 0. What this means is R is equal to 10%, or R is equal to negative 230 upon 3. Now rate cannot be negative, so since a rate can't be negative, therefore R is equal to 10% per annum. Now that's the reason why I asked you to put a star on this question, because this gets converted into a quadratic and then it takes time to solve a quadratic equation. Good, interesting question. That brings me to the last question of this exercise that I solved with you, which is question number 10. It says, on a sum lent out at compound interest, interest for first, second and third year are given. Okay, so then basically this concept is difference between the compound interest of two successive terms. That's basically the concept. So find the rate for the second term. So compound interest 2 minus compound interest 1 is equal to 1725 minus 1500, which is equal to rupees 225. Therefore 225 is interest on the first year's compound interest, which is 1500 for 1 year, which means 225 is equal to principal, which is 1500 into rate. This is for the second year because this is what we are looking at, into 1 upon 100. So that's 225 is equal to 15 R2. Therefore, R2 is equal to 15% per annum, which means the rate for the second year is 15%. Let's look at the second part of the question, rate for third year. So we'll use the same thing for compound interest 3 minus compound interest 2. In this case, 2070 minus 1725, that 1700, that 345. Yes, correct, that 345. So 345 is interest on the second year's compound interest, which is 1725 for 1 year, and this 1 year is basically the third year. Let's put it in the formula. Interest is equal to principal into rate. In this case, we are looking at the third year's rate, into 1 upon 100. It means R3 is equal to 345 into 1725 upon 100. Sorry, 345 into 100, cross multiply, my mistake. 345 into 100 divided by 1725 into 100 upon 1725. That 345 ones are, this is 5 times 520. Therefore, rate for the third year is 20% per annum. Good, that finishes this video for me. Couple of homework questions, question 1, question 4, question 7 and question 8. Take care, be safe. I'll see you with the next video. Bye bye.